All right, so guys, just by way of full disclosure, so I told you a couple days ago that you were not going to take a comprehensive final in this class, right?
Yeah.
That we will do a last unit test, but we will not take a comprehensive final. Guys, please understand, though, that that doesn't mean that we are not going to use some of the work that we do in the next month and a half to allow you opportunity to demonstrate final mastery of some of the things that you've learned to do this year. And guys, what you're going to find out is this lab is kind of like a lab final. So there are things, calculations, ways of structuring calculations that you guys have learned throughout the year. Finding mass by difference, doing dimensional analysis, things like that. Writing down equations before we do calculations. Organizing calculations in logical, well-structured ways. Guys, this lab that you're about to do is your final for that. All the rest of the labs that we're going to do this year are largely non-mathematical. So this is the lab that we use as your final opportunity to show us that you know how to do calculations well. So, guys, with that said, these are the calculations. You'll be doing a mass problem that leads you to a theoretical yield. Then you will be doing a percent yield calculation. Guys, the only difference is this. Let me get my board going, and I'll show you the difference. So in all of the questions that you answered in this homework assignment, you were being fed numbers. Guys, the difference in the lab, I can't get that to move. The difference in the lab is that this number and that number will not be provided to you. Guys, these two numbers you are going to come up with through measurement and calculation, and those will be mass by difference, and you know how to structure those. So guys, you will come up with the mass of your reactant. You will figure out the mass of your known product, and you will then be structuring all these calculations from there. So guys, bottom line is this. When you write up this lab, don't guess. Don't do what feels right to you. Do it correctly. And if you don't know what correctly looks like, guys, there's all sorts of resources, including I will actually post an example of what this should look like on our website. Guys, with that said, on the test that you're going to take on Monday, the last page of the test is just like the lab write-up. So guys, bottom line is there's a lot of things that are coming to bear in the next couple days. So here's how we're going to approach this. We're going to answer your questions about the homework, because that's foundational to the lab. Then guys, you're going to have time today to do the lab and analyze your data. The labs are due on Monday. If you want to scratch that across the top, these are due on Monday, which gives you tomorrow. If you'd like to come by tomorrow after school, I'd love to look over your labs with you. If nothing else, I certainly encourage you to compare with the example that will be posted on our website. And then guys, when you sit down to the test on Monday, the very last page of the test is this. It's just a blank sheet of paper with a data chart, just like the data that you're going to collect today in lab, and you're going to analyze that data, and you're going to do the exact same write-up process in your lab on the test on Monday. So guys, please be aware of all of that. So with all of that said, what questions do you have about the homework as we prepare for the lab? You guys okay? You'll ask if you're not, right? You're good? Do you need to look at any of the other problems? Happy to go where you want. Go ahead. Well, so you're actually given two pieces of information. You're given the 8 grams of oxygen, and you're given the 2.3 grams of water. Correct. And you'll be weighing things. Let's do this. I love that you're thinking ahead. Let's look at the lab in just a minute, and then if those questions are still present, ask them. Okay, what else, y'all? Anything on the homework? You guys are okay? Okay, so guys, make note to yourself to record your homework before midnight tonight. Guys, let's just slide the homework out of the way, although I wouldn't put it away because this is the foundation for all the calculations you're doing in lab today. So guys, grab the lab handout and let me switch up my screens and let's get together and talk about what this is going to look like. So get rid of this, get rid of this, get rid of that, get rid of this, and let's grab a hold of this. All right, so guys, with the lab in front of you, what I would encourage you to do is turn your attention to the reaction that is down at the bottom of the page. Before we get into this, let me mention this though. Guys, please, I know this sounds stupid, right? But please make sure you study for Monday's test. This is a very information-rich test. It's the most free response that you've ever done. You've got an entire page where you're doing these calculations. You'll be balancing equations. You'll be identifying reaction types. Because this is a pretty dense test. Make sure you prep for it. So, with that said, let's talk about what you're doing in lab today. So guys, part A in the calculations of the lab, not surprisingly, says write a balanced equation. So now you're going, wait, why does it say write a balanced equation and then you gave us the balanced equation? Guys, the reason is this. What kind of reaction is this? Single, double, decomposition, synthesis, or combustion? It's a trick question. It's none of those. Guys, this reaction is not one of the 5 reaction types that you have been exposed to. This is actually what's called an acid-base neutralization reaction, and we're going to learn more about those in the next unit. But because this is not one of the 5 reactions that you learned about, guys, there's no way for me to ask you to balance it. So let's talk about what's going on here. And guys, I would encourage you to write this stuff down with me. So here's what you're going to see. Sodium bicarbonate will be a solid. So let's just talk about it. Do you guys know what sodium bicarbonate is by any chance? No, it's baking soda. Yeah, so guys, we are going to take solid baking soda, which is a base, and we are going to react it with hydrochloric acid. Now guys, this is going to be 1 molar hydrochloric acid. So what subscript goes on the hydrochloric acid? AQ. Yep. All right, so guys, when you do this, now look at your products. You've got table salt, carbon dioxide, and water. So guys, this is what you're going to do in lab. HCl is going to be your excess reactant. You're going to have an entire squeeze bottle full of hydrochloric acid. Now guys, sodium bicarbonate, baking soda, is going to be your limiting reactant, and you're going to have about 1 gram of sodium bicarbonate. Now guys, here's the deal. Not less. You can have more than 1 gram of sodium bicarbonate, but do not get less than 1 gram of sodium bicarbonate. Doesn't have to be perfect, just not less than 1 gram. Why not less than 1 gram? Because if you have less than 1 gram of sodium bicarbonate, you lose a significant digit. So guys, we're going to use more than 1 gram, not a ton more, just not less. All right, so then guys, this. Over in your products, this is going to become your known product. Guys, the sodium chloride is the product that we are going to isolate and weigh, and that is then going to become the thing we're going to do the percent yield for. So guys, the trick then is if we are going to isolate and weigh the sodium chloride, the table salt, we've got to get rid of the other products. So guys, how do we get rid of the carbon dioxide? It just bubbles away. So let's put a G beside that for gas, because this just bubbles away. So guys, as you do this reaction, you're going to see bubbles. That's the carbon dioxide leaving. So as the carbon dioxide leaves, you're then going to be left with salt and water. So how do we already know to get rid of the water? Boil it off. So guys, this is going to be a liquid, and we are going to boil away the liquid, and when we do, we're left with the salt. So guys, that's what we're going to do. We're going to weigh out a fixed amount of sodium bicarbonate. We're going to react it with just enough HCl. When we're done, the carbon dioxide's gone. The salt and the water will be in an evaporating dish. We're going to heat that up, boil off the water, collect the salt. Do you get the idea? Okay. Exactly. But that brings us to a problem, right? Guys, do you remember when we did this very same thing in the salt and sand lab clear back in September? Remember when you were boiling off the water? What happened as it started to get thick and pasty? Do you remember? The salt started shooting everywhere in the lab. Do you remember that mess? Now guys, when we did that in September, it didn't matter because we were just trying to dry out the salt. Guys, now it does matter. Why does it matter that we don't want salt flying out of our dish? That's our yield. So guys, if we lose salt, that's going to be our yield going away. So how are we going to fix the problem? Do you remember? Put a lid on it. So guys, here's what you're going to do. I don't think you need to draw this, but what you're going to do is this. Remember, the evaporating dish is this guy, and then we are going to put a watch glass on top of the evaporating dish. Make sure the watch glass is concave up, because if you put the watch glass on there concave down, then all the water is going to condense and drip off the edge of this. So guys, put the watch glass on there concave up, and then as the salt tries to splatter, it'll just fall back down. So that's how we're going to take care of the splattering salt. Yeah?
Will we have to measure adding the concave thing?
Look at your data. Guys, if you look at the data chart, notice what it says, the mass of the dish and the glass. So we're going to weigh the glass and the dish at first because some of the salt's going to stick to the glass, and we may as well just weigh the whole thing so we don't have to scrape it off. So any questions about the procedure and sort of the logic behind what we're doing? You okay? Okay, guys, there's one more thing that I want to mention to you, and then we're going to talk the details of the lab. So you know that you're going to carry out this reaction in an evaporating dish. So guys, here's what you're going to do. You're going to get your about 1 gram of sodium bicarbonate, and it's a solid, and you're going to put it in the bottom of your dish, and then you're going to start to add acid. Now guys, picture this in your mind. You start adding acid to the sodium bicarbonate, what are you going to see? You're going to see bubbles. So you're going to go drop, drop, bubbles, drop, fizz, and then guys, eventually what's going to happen is you are going to end up with the sodium bicarbonate down here, and then you're going to end up with a puddle of acid sitting on top of the sodium bicarbonate. Guys, make sure you stir this, because if you don't stir it, then you're going to end up with unreacted sodium bicarbonate at the bottom, and that's bad. So stir the reaction as you go. But here's the trick. Sodium bicarbonate dissolves in water. So when the sodium bicarbonate dissolves in water, guys, eventually you're not going to be able to see it, but it's still there. So here's the question. How do you know when all the sodium bicarbonate is gone? Go ahead. Oh, were you? Guys, how will you know when all the sodium bicarbonate's gone if you can't see it? Go ahead, McKay. Exactly. It stops bubbling. So guys, what you're going to see is this. You're going to stir this, and the sodium bicarbonate's going to go away, and then you're going to keep adding acid drip by drip, and you're going to go drip, fizz, drip, fizz, then drip, no fizz. That first drop that doesn't fizz tells you that you are out of your limiting reactant. You're out of the sodium bicarbonate. So guys, what happens if you keep then adding acid? And the answer is you're contaminating your product, and you're going to screw up your percent yield. So guys, you're looking for that last drop that doesn't fizz, and then you're done. Does that make sense? Okay. So guys, with that said, read the procedure. By yourself, read the procedure. Given everything that we talked about, what questions do you have about the procedure? Give everybody a minute to give it a read. Let's stay on procedure, and then we'll talk calcs. We're not rushing. Let's focus on procedure first. So guys, any questions about the procedure? Go ahead, Ellie. Yeah, good question. So we're stirring with a stirring rod. We have these little glass stirring rods in lab, and that's a great question. How do we know that some of our stuff isn't on the stirring rod? And the answer is, well, there's many answers. To know for sure, what we should do is take a wash bottle and wash anything on the stirring rod off. But frankly, all of this stuff is so soluble in water that it's just going to stay dissolved in the water. And the little bit that we might lose, unless you've got chunks on the stirring rod, you can trust that it's not a big deal. That's a great question. Guys, what else? So let me ask you some questions. So guys, down in step 5, it says react while stirring with the base with excess HCl until complete. Again, how do we know it's complete? No more fizzes, right? Then guys, when we isolate the HCl or the NaCl in step 6, we're going to do that by boiling off the water. But again, we're going to make sure we have the watch glass on there so the splatter doesn't leave. Is that okay? Okay, then the last thing I want to ask you about is step 3. It says add approximately 1 gram of sodium bicarbonate to the dish. So guys, how are we going to get that sodium bicarbonate? In a weighing boat, right? So we've already weighed the dish and the glass, then we're going to get a weighing boat. We're going to tear out the weight of the weighing boat, then we're going to add the sodium bicarbonate to that, and it's going to be more than a gram. A little more, but more than a gram. Is that okay? Okay, so guys, what you're going to see when you go into lab is you're going to have, for each group, you're going to have a bottle of acid, you're going to have a watch glass, you're going to have a weighing boat, and you're going to have a vial of sodium bicarbonate. Guys, they are well organized now. Please similarly organize them well and leave those 4 items on your countertop when you're done with the lab. Yeah?
I just have a question about calculation.
Is everybody done with procedures? Go ahead.
So you mentioned last time that there's going to be some of us who end up with over 100%.
Yes.
Isn't that like make all our calculations valid?
No, not at all. No, it's actually the opposite. Your calculations would be invalid if you fudged your numbers. Understand that your calculations are valid based upon your data. The tricky bit is being able to explain them. So, guys, Sam's question was about what if we get more than 100% yield? Guys, flip your labs over on the back. You'll notice that this gets covered in conclusion questions 1 and 3. Conclusion question 1 says, discuss the possible reasons why your percent yield was not 100%. So if your percent yield is below 100%, that's one conversation. If it's above 100%, that's a different conversation. Does that make sense? Then go down to conclusion question 3. Guys, this conclusion question is a general principle that we talked about in class last time. In general, why is it impossible to have more than 100% yield? So even if you got less than 100% yield, why is that impossible? What law and you got to name the law. What law tells us that you can't get higher than 100% yield? And I want to talk about it now. And then, guys, how can yields over 100% be explained? And guys, don't guess at this. There are answers to these questions. Make sure that you talk about them. I don't want to talk about it now, though. Okay, please.
Just about the first question.
Yeah.
How do you answer the first question if you have an over 100% yield?
Well, so then the answer to the first question would be similar to the answer to your third question. So if you did get 100% yield, talk about why, which is then also the answer to why that's possible in general. McKay, you had a calculation question. Hold on a second. What are you calling A? Well, A is the balanced equation. Are you okay? Yeah, so guys, could we maybe visualize what this might look like? So you'll notice on the front it says calculate the mass of the sodium bicarbonate. I don't think I'm giving anything away if I said that that will be a subtractive process. But guys, remember, we do mass by subtraction in a very defined way. If you're not sure how to do that, go back to September's notes, go back to all the other labs that we've written up. Guys, there's a way to do this right. Then guys, flipping over again, looking at part C, you'll notice that this has actually got 3 subparts. You're going to calculate your actual yield for table salt. Again, that will be subtractive. And then guys, you've got your theoretical and your percent yield calculations. That's just like the homework that we just reviewed. And guys, please remember, if you're using an equation, you've got to write it down first. So guys, when you get home, as you're starting to write up this lab, if you find that your lab's becoming a mess, print another copy. Don't turn in something with crossing out. You're going to do, this is high quality work, right? That's probably all I need to say. Don't do it in pen. Do it in pencil. So guys, any questions about any of this? Y'all good? Okay. Oh, I'm sorry. Oh, sorry. Thank you. Yeah. Did you say B? Keep going. No, it's going to be about, and that's a great observation. It's going to be about a gram, but it probably won't be exactly a gram. And you need to know exactly what it is. And therefore, we weigh the dish in the glass, then we add the stuff, then we weigh it again and subtract. Yep. What else, you guys? Y'all okay? So gang, I think you're starting to appreciate that the lab is quick, but the expectations are high. We're going to go goggles first. Everything you need in lab is there. Again, I'd love to look over these labs with you on Thursday or tomorrow. And then guys, please remember, all of this stuff comes back again on Monday's test. So, you guys good to go? Let's do it. See you next door.